Alright, so today we are talking about sections 3-4 and 3-5, parallel and perpendicular lines, and parallel lines and triangles. So a lot about parallel lines. So let's first talk about 3-4, parallel and perpendicular lines. And we have a new vocabulary word, and that is perpendicular lines. And perpendicular lines are just lines that intersect at a 90-degree angle. So here we have lines A and B. Now, in order to show that they are perpendicular, we put a rectangle or a square in the corner. Now, our notation to say that line A is perpendicular to B, we can write it like this: line A, perpendicular to B. And this says line A is perpendicular, an upside down capital T, to B. So this word right here means perpendicular. Now we can look at some theorems from this section. Theorem 3-8. And this is a fairly obvious theorem. 3-8 simply says that if you have two lines that are parallel to a third line, so right here A is parallel to B and B is parallel to C, so both A and C are both parallel to line B. So here's A is parallel to B, that's these marks, and B is parallel to C are these marks. Well, the conclusion then is that lines A and C must also be parallel. Next theorem, theorem 3-9. This theorem says that if two lines are perpendicular to the same line, then they are parallel to each other. So let's look at this. Line M is perpendicular to line T, there's our perpendicular symbol, and line N is perpendicular to T, and therefore M and N must be parallel. It's pretty easy to prove that this theorem works. The way that we drew these angles here, these are corresponding angles, and corresponding angles are congruent, therefore the lines are parallel. And our next theorem is going to be theorem 3-10. This one does have a name. This theorem is called the perpendicular transversal theorem. And the perpendicular transversal theorem says that if you have a line L that is perpendicular to a line and parallel to another line, so L is perpendicular to one line and parallel with another line, then the other two lines must be perpendicular. Again, that is called the perpendicular transversal theorem. And so that is really it for 3-4, parallel and perpendicular lines. It's mainly these three different theorems and some problems that go along with it to determine if lines are parallel or not, using these theorems along with the theorems from the last section. So a quick recap. We have perpendicular lines. Those are lines that intersect at 90 degrees, like the picture here. Our notation says that line A is perpendicular to line B. And remember, perpendicular lines, we have to put a little square. That shows that it is 90 degrees or a right angle. Let's go ahead and show 90 degrees. Then we have three different theorems. Theorem 3-8, Theorem 3-9, and 3-10. 3-8 says that if you have two lines that are parallel to the same line, so B and A are parallel, B and C are parallel, therefore A must be parallel to C. Theorem 3-9, if you have two lines that are perpendicular to the same line, so M and N are both perpendicular to T, therefore those two lines must be parallel. And Theorem 3-10, the perpendicular transversal theorem, says that if we have a line L and it's perpendicular to one line and it's parallel to another line, then those other two lines, N and M, must also be perpendicular. Now let's go ahead and look at 3-5, parallel lines and triangles. So we have a postulate. Remember, a postulate is something that we can just assume to be true. Postulate says through a point, not on a line, so here's a point P that's not on this line L, there is only one and only one line parallel to the given point. So I could even choose another point, let's say point down here, call this point Q, and so a line that's going to be parallel to L that goes through Q would have to be a line, not a real parallel line, but you get the idea is there's only one line that can be parallel with line Q. So our next theorem is theorem 3-11. This is the triangle angle sum theorem. And the triangle angle sum theorem simply says that the sum of the measures of any triangle, so some of the measures would be the interior angles. If you add up the measures of these three angles of this triangle, it will equal to 180 degrees. Or we could say the three angles of a triangle combined are all supplementary. Altogether are supplementary. So let's go ahead and look at an example using the triangle angle sum theorem. So here you see that we actually have three different triangles. We have triangle ABC, we have triangle ABD, and we have triangle BDC. So three different triangles are included in this picture. Our job is to find the measures of angle X, angle Y, and angle Z using the triangle angle sum theorem. So let's start by trying to find X. So let's look at triangle ABD. ABD, this triangle right here. And let's pull it out so we can look at it a little bit better. So in order to find X, we know that the sum of these three angles has to be equal to 180 degrees. So we get the statement 43 plus 59 plus X, those three angles add up to 180 degrees, and now we can solve for X. And we should get X is equal to 78. So X is 78 degrees. Now let's look at triangle BDC. And let's pull that triangle out so we can look at that individually, and we'll have to fill in our values. So looking at triangle BDC, we have this BDC, and it looks like we have two variables, but we do know that if we were to extend this side of this AD here, that this value X is 78 degrees. That's where we found X. And then to find the measure of angle Y, 78 and Y are a linear pair, so they have to be supplementary. So we can say that 78 plus Y is equal to 180 degrees. And so Y is equal to 102 degrees. And so now to find Z, we know that 49, that was given to us, 102, which is our value for Y, plus Z should equal to 180. That's using the triangle sum theorem. And solving for Z, we should get Z is equal to 29 degrees. To look at our next theorem, we need to talk about another definition, which is called the exterior angle of a polygon. Now we already talked about the interior angles of a polygon. Interior angles are simply the angles inside of a triangle. Exterior angles then have to be on the outside. And to find an exterior angle, what we want to do is we want to extend one of our lines like so, and then this angle that is formed out here is an exterior angle. Now notice, if we had instead extended the other leg of this angle, then we would have gotten this angle as an exterior angle. But notice, if we extend both of them, these two angles out here and here are vertical angles, so they're going to have the same measurement. So when we talk about exterior angles, we only extend one side and know that both exterior angles are going to be the same measure. So we really only have to draw one side extended. And notice each of our vertices of the triangle will have an exterior angle. So for a triangle, we will have three exterior angles, one exterior angle at each vertice, where we have three interior angles. So here's another look at the exterior angles. Then we have the vocab word, the remote interior angles. We already know what interior angles are. When we talk about remote interior angles, that's in reference to an exterior angle. So for example, angle 1 is an exterior angle. 2 and 3 are remote interior angles. They're interior, but they're not adjacent to angle 1. So now let's look at the relationship between the exterior angle and the two remote interior angles. And so we have this theorem, 312, called the triangle exterior angle theorem. And the triangle exterior angle theorem says that an exterior angle is equal to the sum of the two non-adjacent, or the two remote interior angles. So the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. So in these two examples, you can see that our exterior angle 1, measure of angle 1, is equal to 80 plus 18, the two remote interior angles. Likewise, in the second example, 124 degrees is our exterior angle, so it's going to equal to the measure of the two remote interior angles, which is 59, plus the measure of angle 2, and so we can solve for the measure of angle 2 would be 65 degrees. So here's a problem that I'd like you to try. You've got an exterior angle, 10x plus 30 degrees, and remote interior angles of 40 degrees, and this one is 7x minus 9 degrees. So I want you to solve for x and then find the measures of these two angles.